Nice small one. Okay. Let's see. Perfect. Okay, cool. Alrighty, everyone, give me just a moment to draw these lovely images. Let's see. Let's measure. Did a leaf in the other class? Whatever, leaves work nicely. Good morning. Still doesn't look very much like a leaf. Oh well. And let me just draw a second one for us here. Ba-ba-ba. Alrighty, so just as I'm doodling here for us, does anybody have any questions about the scientific notation that we went over last time before we jump into our next topic here? I'll give you a sec to write any questions while I continue drawing. So let's see. Wow, my drawings just get worse each time, don't they? Okay, so far looks like there's no questions. So today we're going to be starting to talk about measurements. So we've already kind of touched on how we communicate numbers. In science, we've talked about like how we can display really big or really small numbers using scientific notation. So that's, remember, it's got something with one number, decimal point, other stuff if necessary, times 10 to the whatever. And so this way it's going to be easy for us to very easily be able to communicate to each other how big our numbers are going to be. Okay, so almost done drawing here. Hopefully everyone had a nice, relaxing weekend. So we'll just get right into it. 4, 1, 2, 3, 4. Da, 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 da. And then let's say it's gonna be maybe here. Okay, cool. Alrighty, so when we're taking measurements in science, relaxing weekend of calculus, yeah, said no one ever, except maybe Newton. Whenever we're taking measurements in chemistry, we're going to see that our the instrument that we're using to take the measurement, that is to say, like the tool we're using, is going to be very important for how we're going to be able to communicate our results. So let's say we wanted to measure this leaf, because we are no longer in chemistry, we're doing biology now. And we had this ruler. Apparently it's 50 centimeters long or so, and it has 4 tick marks on it, each of them being 10 centimeters. So if we were to take a look at this leaf and we were going to try and measure its length, assuming that it's lined up properly, which I tried to do with my drawing here, we can see that this leaf is between 20 and 30 centimeters long, right? We can see for sure that the end of that leaf is falling somewhere in between the 20 and the 30. So it's bigger than 20, less than 30. Hopefully that's pretty obvious. Hi, little dude. Stay down there, okay? If we look further, we can say, okay, you know what? This one is closer to the 30 side than the 20 side. We can go ahead. Let's see if we can't kind of figure that out. If you look, yeah, it's definitely closer to 30. But since we don't have any further marks to guide us as to more specific numbers, we're going to kind of just take a guess here. And so if you were to try and guess how long this leaf was, based on these lovely drawings I've done here, just on the top drawing, by the way, you would probably say maybe it's about, I would say maybe about 28 centimeters, according to this drawing, thereabouts. We can see it's definitely closer to the 30 side, probably not 29, could be 27, somewhere around there, right? We know we have a pretty good idea that that's where our measurement is. However, we are not 100% certain. For sure, this could be 27, it could be 29. We're just kind of making our best guess based on the information that we have and the tools that we're using to get that information. So, we're going to see that if we have a better tool, we're going to be able to make a more precise determination as to the length of this leaf. So, if our leaf now, in fact, instead of just having a mark every 10 centimeters, has one every 1 centimeter, we can see, okay, this one now is going to give us a better estimation of the length of our leaf. So just to make sure, this one right here is 25, right? It's going to be in the middle between 20 and 30. That means that each of these are going to be 1 centimeter, right? Say these are centimeters. And so now, if we go ahead and try and measure our leaf, okay, now we see that it's going to be in between 27 and 28 here. So before, we were only able to say, okay, it's bigger than 30 or 20, less than 30. Now, because we can see where 27 and 28 are, we can say for sure it's between those two numbers. And so again, we're going to kind of look and say, okay, it's maybe just about halfway in between those. Maybe it's, it could be a little bit closer to 27, maybe. Fun, thing we can just zoom in like crazy. Technology, hooray. We can say, okay, you know what? I'm probably going to say this is about halfway through. Hopefully no one thinks, something terribly different. So we could say maybe it's 27.5 centimeters. And so again, we're going to see that we know for sure it's bigger than 27. We could see that. 27 is right here. We know it's farther than 27. We know it's less than 28. So the only one that's not 100% certain is, again, that last digit. And if we just go kind of one step further, going completely crazy on this, if we zoomed in again on our ruler, we're going to see that now if I've got 27.1 and 27.2 and blah, 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 I guess I'll need 27.3. We could see that our leaf is going to be, in this case, I've tried to be consistent, but, it's super hard to draw these, nicely. So, oh well. So, we know now it's between 27.2 and 27.3. Again, because we have these provided for us with our ruler. This is now a very expensive, fancy ruler that has 0.1 centimeters on it. So we can use this information to say, okay, you know what? Again, it's kind of halfway in between. Just for fun, I'm going to say maybe it's closer to 27.2. Just a little bit. And so, okay, I might be able to say, you know what, this is exactly, or perhaps 27.24. Maybe I said 27.25, 27.23. Again here, what we're seeing is that we have only the last digit is uncertain. Okay, so again, not 100% on this. So if I were to ask you to measure something, I would totally accept 27.23 for this one, or on the one before 27.4 or whatever, as long as you're close to it, right? Because we're just kind of using our best judgment, using our eyes to kind of make that determination. However, because we only have one number that's not 100% certain, these ones we know for sure. So everything that is certain, we do know 100% for sure. And it's only going to be that last digit that is going to be not 100% certain. Okay, and so you can see from our kind of crappy ruler to the medium ruler to the really fancy precise ruler, our measurement has changed a little bit, right? We were able to say, okay, first, we started at 28, and then we went to 27.5, and then we went to 27.24. We can see here that, this one gives more information, right? It's more accurate. It's more precise, right? Whereas this one's kind of vague and giving us less information. And so we're going to see that in science, of course, we want to have as much information as possible, right? If you're planning a trip to the moon or whatever, the more information you have about your measurements, of course, the better it's going to go. Because maybe 28 versus 27.24 is the difference between landing on the moon and, accidentally going past it or something. These could make a big difference. While, maybe for us, it's not exactly the biggest difference in the world. These can be important when you come to more, sensitive things. Alrighty, so what we see here is better instruments is going to be equal to better measurement. Now, of course, better instruments are often more expensive. So, that's why, NASA and all these, they're having, $1 million or multi-million-dollar instruments to take measurements of things. Just typically because the better your measurement is, the more it costs to produce. And so we're going to see that carrying that information along is going to be very important for us. Notice also with these, we always kind of read it one more place than we can see for sure. So remember, between the 20 and 30, those were tens places, right? 20, 30. We read then to the ones place because we wanted to say, okay, it's closer to 30. Let's go ahead and make that determination. We're going to kind of guess that it's an 8, but we are measuring one more place than we can see. For sure, we can see 20, we can see 30. We're going to kind of read it one more spot. Same thing with the next one. We saw it's between 27 and 28 for sure, and we're going to use our best judgment to kind of make that determination that it's in the middle. And same thing and so forth. So we always read one more place than you can see. Okay, so in green, because why not? Always read one more place than you can see for sure. Okay, so this is going to be how we're going to be able to do this. So if you were to look at this very first one, again, this between 20 and 30 thing, it would not really make sense to go straight to 27.24. I mean, how the heck would you be able to see that much information from this crappy ruler? If you were to say even, is this 27.5? That would be a stretch as well. We can only kind of see one place beyond what's marked on our instrument for us. Okay, so never kind of, on this first one, if I gave you this ruler and this leaf and you told me 27.24, I would say, BS, you're crazy. Like, there's no way you can have that much information. Okay, so just one place more than you can see. And it's understood that the last digit in measurements is uncertain. Okay, so we all accept this whenever we're doing a measurement that is with, our eyes or something. So, practice time. Let me draw for you. Let's do a graduated cylinder. Because I want to also talk to you about how we can measure liquids. Okay, and let's say that this is 5 ml, 6, 7's up there. Oops. And I'm just going to do these in a different color because why not? Yeah, we don't really need more than that anyway. So, okay, cool. So, with liquids, we may have seen this in your life before. Liquids in relatively narrow glass containers tend to, they'll be attracted to the glass, and so they're going to kind of move up a little bit on the sides. This is what's called a meniscus. That's that kind of U shape that we're going to see. If you look at a glass of water very carefully, you'll probably be able to see that it's moved up on the sides a little bit. That's a meniscus as well. We always want to take our measurement from the bottom of the meniscus. Okay, so we're going to kind of ignore the stuff on the sides. Okay, this is kind of, I apologize for making the let's see. Internet is awesome this morning. Awesome. Yeah, I know. It's bad times we're living in right now. Bad times across the board. So we're going to always read the bottom. Okay, so we're never going to take our measurement from the top of the meniscus. Always the bottom. Alrighty, and so I've kind of drawn our, line from the bottom of the meniscus to the edge on the cylinder here, and so kind of crappy here. I'm gonna adjust this just a little bit, just to make it a little bit easier for us. Okay, so just to make this a little bit easier, let's put it kind of like this. Okay. I realize it's kind of crooked, but again, hand-drawn stuff, not so easy. Okay, so what do these little blue lines represent on our graduated cylinder? We know these kind of bigger black lines are 1 ml apart. And if we look, we have 10 of those in between, like 5 and 6, for example. That tells us that, let's see which color, how about purple today? That this little dude here is, that's really awful. I guess because I'm so zoomed in. Here, let's make it thinner then. So that means that little line there is 6.1 ml, right? So if we look at that, we're going to say that this is for sure in between. I'm going to zoom out here just so it's not so crazy. Back to normal. Our measurement is going to be in between 6 and 6.1, right? Yeah, I know, Paulette. There's always buffering with slower internets, so it's unfortunate these things are optimized for better internet that we don't have in Ridgecrest, so, or India, or wherever you guys are. So I want you guys to come up with a number that you think this measurement could be. So go ahead and put something in the chat there. I really hope that you're going to give me something in between 6 and 6.1. Let's see it. Put some numbers out for me. Okay. Seems reasonable. Okay, also seems pretty reasonable. Okay, we're kind of all over the place, but we are actually I like all of these things that you've given us. So far we have let's see. We had 6.05, 6.07, 6.03, 6.04. All of these are great. It could be any one of these because we understand that our last digit here is uncertain. So the 5, the 7, the 3, and the 4, all of those are not quite certain. And so as a result, all of your measurements are going to be correct. It just kind of is what you see. All right? And as scientists, we understand that different people who look at this thing may measure it slightly differently. Like some of you have measured 6.05, some have measured 6.04. You're both right. It's just whatever you can see. We understand it is definitely 6.0 something. We all understand that. Okay, and it's just that last digit there that we're not so certain about. Okay? So, you're all right. Of course, if I were to give this on an exam or whatever, and you were to put in any of those numbers, you would be just fine. Okay, so again, we can see, we saw 6.0. We saw 6.1. So we see, we read it 6.0 something. All right, because we can see the tenths place, we want to read it to the hundredths place. Okay, we saw tenths place for sure, read to hundredths. Alrighty, any questions on how to read measurements like this? I don't know if any of you have been neurotically checking Canvas, but I have put 2 homework assignments for us so far. And the first one is going to be based on these sorts of measurements. So, after the lecture, you're welcome to take a look and start it. Of course, we will not have completed the, everything that's in that worksheet. So you will not be able to go as far as completing it probably, but you'll at least be able to get started on it. Okay, cool. So we're going to have a way. So if you remember before, we had that 28 versus 27.5 versus 27.24 or whatever they were before. We had those numbers. We have ways of talking about these in science, okay? We're going to say that this number here has 2 significant figures. Okay, those we abbreviate SF, significant figures. This one here is going to have 3 significant figures. And this one will have 4. We're going to see that more significant figures is better measurement. Yeah, exactly, Sabina. Very nice. And we're going to have rules and signs for talking about how many significant figures a particular number has. And so what you might have already deduced, our kind of first rule here is any number 1 through 9 is significant. Okay, so just like before, we saw 28. It's got a 2 and an 8. Both of those numbers will be significant. 27.5, all of those are going to be significant figures, as well as 27.24. All of those are numbers 1 through 9. And we're going to say that those will always be significant. Okay? So far, so good? Well, I mean, that's just the first rule here. We're going to have a second rule, which is going to tell us any 0 before significant digits, let's see, before a 1 through 9, is not significant. Okay, so if we do some measurements, or rather, let's just throw in some things here. If I were to take our number 28 and stick a 0 before it, because why not? I could say, yes, this number is 028. It'd be kind of really absurd to say that. And we would never say that because we already know in our minds there's no point to putting a 0 there because it doesn't matter. So this 0 does not count for our significant figures. Nope. However, these still will. So our number 28 still has 2 sig figs. Bit of a strange example, but let's do another one. If we were to take a look at this number, we're going to see that this number has 2 zeros that come before numbers 1 through 9. So those zeros are important. However, they are not measurements for us. Those zeros will not be significant figures. And so this number here will have 3 significant figures. We're going to see that these zeros do matter, though, because these are placeholders. They're there to let us know that this is a really small number, but other than that, they do not convey information. And we're going to see that if we put numbers into scientific notation, it's going to make it very easy for us to see which numbers are significant. So if we were to put this into scientific notation, that would be 6.12 times 10 to the negative 2, right? Hopefully nothing too confusing there. We see right there for us are our 3 sig figs. These two numbers were the same, right? Scientific notation versus regular number. They're exactly the same, identical number. We're going to see that we want to have the same number of sig figs as well. Okay, so these two numbers are identical. They have the same number of sig figs. So zeros that are before a number are going to be used as placeholders, and they're not going to be significant. Okay, and again, a way to easily get around this without having to really remember this rule is if you just throw it in scientific notation, you will avoid the problem of having zeros at the start of your number. Alrighty. Our third rule for determining the number of sig figs a number has is any 0 in between 1 through 9 is significant. And so, if we just go ahead and take some numbers here, we're going to see that, of course, our numbers 1 through 9 will be significant. Always, always. We remember from our second rule that these two, anything at the start that's a 0, will never be significant. Those are placeholders. But what do we do about this 0 here? The one in between 2 and 6. We're going to see that that will be important. So this number will have 4 sig figs. The reason for that is if we go back to our handy-dandy grad cylinder measurements, look at all of these numbers that we have here. We understood that 0 came from a measurement. And as a result, we measured that 0, and so it will be significant. So anytime we see a 0 in between numbers, that 0 will be a significant figure. Okay, it has a meaning. Okay, it is conveying something about our measurement. Alrighty, so same thing doesn't have to be, just throwing out random numbers here. How many sig figs is this one going to have? And then let me do another one here. How many sig figs is this middle number going to have? Yeah, I like it. Right. 1, 2, 3, 4, 5 for sure. We always have our non-zero numbers. And since we look at these zeros, they're in between numbers, right? So we will count those as well. So this will have 7 sig figs. Alrighty, and how about the last one? Here's the tricky one here. So, of course, we'd have at least 3, right? Yeah, so 6. Now that's interesting. Not sure. Well, we'll see. Okay, so let's look at that first 0. 0 on the left. Is that 0 going to be significant? Guess you can already see I've chosen red, so no, it's not. We're also going to see this one also is not significant. Right? It's still a 0 at the beginning, right? Yeah, so 5 will be the answer here. So, and then we see we have zeros that are in between other numbers, right? They're in between 1 and 9. So it doesn't matter how many zeros are right there. Could be 5 zeros in a row. As long as there is a regular 1 through 9 number on each side of those zeros, they will count. And so as a result, this number will have 5 significant figures. Alrighty. One more step here. The most confusing rule. Well, maybe it's confusing. Our last one. Should say any 0. Oops. At the end of a number. Indeed. Uh-oh. Significant only if there is an explicit, big there, decimal anywhere in the number. Okay, I realize this is very long and verbose. Okay, so zeros at the end of numbers will only count if there is a decimal somewhere in the number. Okay, explicit means it's actually written out. So, for example, this, if we look at these three numbers, for number 3 here, there is a decimal in the first number and the third number, but not in the middle number. Okay, yeah, we understand that there would be a decimal after the 6 in the second number, but it's not explicit. Okay, it has to be written in for it to count. And so, if we take a look at a few numbers, let's see here. Let's take a look at these three numbers here. So, of course, for this first number, yes, 2 in 1 count because they're 1 through 9. We want to see, okay, a 0 at the end of the number will be significant if there is a decimal anywhere in the number. So, hopefully, so again, internet troubles, sorry, nothing I can do about that, but remember, it'll always be available for you. So at midnight, you are welcome to watch us on YouTube and, enjoy a glass of wine or something, and have fun with it later. So again, apologize, but sorry, nothing I can do. Okay, so looking at the 0, we see a decimal in this number. That tells us the 0 at the end is significant. So, 3 sig figs. Alrighty, so if we look at the second number now, again 2 and 1 will count, always. And okay, do we have a decimal in this number anywhere? Yeah, unfortunately, the fires are really messing up everything, along with just... Yeah, it's unfortunate, but we'll just all have to make do, so... Yeah, hopefully none of this will affect you guys during the... so sorry. Sabina, you're absolutely correct. So, because there is no decimal in this thing, that 0 does not count, and so we have 2 sig figs. Perfect, perfect. Notice one more thing. This may surprise you, but 21 is not the same as 210, right? If you'd be asked, do you want $21 or $210, hopefully you'd make the right choice there. But have 2 sig figs. Okay, both of these numbers do have two sig figs, but they are not the same number. Okay, that 0 at the end is a placeholder also. Just like we had placeholders before, we could have placeholders after a number. Okay, so that 0 is there to tell us it's 210 and not just 21, even though it only has 2 sig figs. Alrighty, however, if we wanted that 0 to be significant, we could put a decimal point. If we have a decimal point anywhere in our number, that 0 will count. So this number is 3 sig figs. Okay, and if we really wanted, we could go ahead and say, we have these numbers here. We're going to see mathematically, yes, these are all exactly the same number. No problem. However, each of these has a different number of sig figs. And so, yes, while mathematically they're the same for us, the one on the right, the 210.00, is a much more precise measurement. So that number must have come from something that we could see exactly where those zeros were. So these will matter. Okay, so we can see, for example, we'll have 2 sig figs, 3 sig figs, 4 sig figs, 5 sig figs. Exactly the same number, but different numbers of sig figs. All right. So far, so good. We'll practice. We're going to put all our rules together now, okay? So, let's do a couple more. Here we go. Let's see. Alrighty, so here's a bunch of random numbers that I've come up with. Presuming these are measurements, of course. We'll pretend. So, I want you guys to tell me how many sig figs we have. And in the meantime, while you're doing that, we have Oz here, who has just been napping in my lap. And now he's trying to stretch, but I'm still holding him, so he can't really do that so easily. How interesting. I look very blue today. Lighting is very strange, I guess. Who knows? Probably fires again causing weird things, so. Alrighty, so who's got the first number for us? How many sig figs in that first number? Yes, absolutely right. Very, very nice. Very, very nice. So, you better say at least 3, okay? If anybody says 2 or something, forget it. Yeah. This one, sometimes he goes crazy with the barking, but usually in the morning he's too sleepy, so he's okay. Alrighty, so we have 2 zeros to worry about in this number. We have a 0 that's in between 2 numbers, and we have a 0 at the end. So, we can go back up to our rules. Okay, which one of these deals with zeros that are in between? That'll be number 3. Rule number 3 says it will be significant. So, significant. We also have a 0 at the end. Rule for that is we have to look if we have a decimal somewhere in this number. And do we have a decimal? Oh, look at Maya just going crazy. I love it. Okay, we'll see if you're right. Okay, so yeah, we have a decimal here, right? So that tells us that this number is significant. So this will have 5 sig figs. Okay, looking at the second number, Maya has predicted this will be 4. And so let's see if she's right. So 628 for sure. Easy, easy. We have zeros at the front and a 0 at the end. Zeros at the front, never consider zeros at the front. Okay, they are not going to be significant. Alrighty, we have a 0 at the end. Is there a decimal? I see a decimal. That means we have a significant 0 there. So this should indeed be 4. Which one is 6? You were correct if you said 4. Yes, don't do that. Okay. Third number, Maya has predicted 4 again. Let's see if she's right. Okay, 1 and 3 for sure. So now we have zeros in between. Zeros in between are always significant. So, yep, for sure. This will also have 4. Alrighty, so next number, Maya has predicted 4, but I agree here that it says next one is 1. I'm going to agree there. So, we have a 1, right? Definitely significant. We have all these zeros at the end, but I do not see a decimal in this number. So no decimal means those three do not matter for significance purposes. So we only have one sig fig here. And so, Maya, those 4 zeros that you just wrote in chat also are not significant because there is no decimal. So, I know they're O's. Yeah, exactly. No decimal means not significant. All right, and let's see, you've predicted 3 for the next one. We have the 1 for sure. All right, and then we have zeros at the end. Good, good, good. That's the point. We're going to hopefully give you ones that are make you think a little bit. So, we have 2 zeros here, and they're at the end of a number. So, if they're at the end of a number, 4 because we moved the decimal, well, just look, how many zeros do we have in this number? We have just these two, right? We're trying to figure out if those guys are significant. And so we are going to look back to our rules and say, okay, yeah, we have a decimal. It's right there. Scientific notation, remember, always has a decimal. So we are going to count these things. And that'll have 3 sig figs. All right, just to make sure, let me just do this in purple. This part doesn't count for sig figs. Okay, so yeah, you just completely ignore it for right now. That's just an exponential. It's there to help us understand that this is actually 1,000. But yeah, we're just gonna ignore that for now. Actually, not even for now. We're always gonna ignore that for sig fig purposes. Okay, sorry, I think I did not make that clear earlier, so you are forgiven. As am I, hopefully. Okay, the last one here. 2 and 8. Absolutely. Okay, and we have 2 zeros here. We have a 0 in between numbers, and we have a 0 at the end. So 0 in between, yes. 0 at the end. Oh, let's see. We're having... I like this. I like this. 0 at the end. So we ask ourselves, is there a decimal? I don't see one. I would agree. 0 at the end is a no-no. Because no decimal. There's no decimal, so that 0 does not count. So this one should have 3 sig figs. Indeed. Yeah, so I'll do this one in red as well. No decimal. Oh, that's really ugly. Oh god, it's just getting worse. Okay, there we go. Kind of. So if there's no decimal, you cannot count the ones at the end. Yep. Tricky, tricky. So hopefully the first 3 rules are not too bad. 1 through 9 always. 0s at the start, never. 0s in between, always. Those 3 rules should hopefully be not hard. It should just be that last one that's the tricky one. So that's the only one you have to watch out for. The rest of them are hard and fast, so we don't have to worry about those. Okay, notice I was... let's see here. Working with these numbers here. Again, notice these 2 numbers. Again, notice that these 2 numbers are equal, right? They're both 1,000. All right. Mathematically, again, same number, but chemistry-wise, different number. Okay, remember this one we saw 1 sig fig, this one had 3 sig figs. They're both 1,000 mathematically. However, this one on the right has come from a more precise instrument. It'll get more fun, Maya. That's what I'll say for this. Okay, so there's a point to all this. We're not just going to count sig figs randomly, right? We're going to see that there is a purpose to the madness here. So we're going to see that we're going to have to take. We have to think about sig figs whenever we do math. Yep. So let me let's do it. So we're gonna have a rule here that's gonna be when multiplying or dividing, we are going to always round to the lowest number of sig figs. Okay? So that means if we have 512 divided by 20 with a decimal point, if we do the math, computer, 512 divided by 20.
512 divided by 20 is 25.6.
Okay. Alexa has told us that it is 25.6 if we do the math. So, looking at this number, we're going to want to understand that 512 had how many sig figs? No zeros here, so it should be easy. This number here had 3 sig figs, right? The number on the top. And if we look at the number on the bottom, that one should have 2 sig figs, right? I'll just put sig figs up here, just so we all know what those numbers mean. Right, so whenever we're multiplying or dividing, we're going to have to round our number so that it has the same number of sig figs as our lowest significance number. And so between 3 and 2, 2 is less, right? So we need to round to 2 sig figs. All right, and anytime we are rounding, the ones on the left are more important, right? The 20 and the 5, like those are more certain. We always remember the last digit is the least certain, right? It's uncertain. So we know we're going to keep this 2 and the 5. And so what we have to do is now think about, we want to look one more and round it up or down, depending. And hopefully you remember from whenever you learned how to round numbers. So we're going to look at this 6 here and say, okay, it is bigger than 5, right? So we are going to round up to 26. All right, we rounded up because that next number was 5 or higher, right? If it's 5 or higher, you round up. If it's 4 or less, you round down. All right, and so our final answer here should be 26. Okay, so we always have to convey our significance with our numbers whenever we do math in chemistry class. Okay, or physics probably. You'll be doing the same thing there. Okay, so if we do another one, on our calculator, I'm just going to go ahead and do this here. 602 times 0.08210. Okay, so if we plug this in our calculator, or on Google, or on whatever your phone, you will get this as your number. Okay, however, we must always take into account our sig figs, because we are going to have to round our numbers. Aha, I've possibly tricked you. So I agree with this one. That one had 4 sig figs, I agree. But this one's got 3. Right, 0 in the middle does count, always. Where did 7 come from? There aren't even 7. Yeah, exactly. So anyways, so we look at the lowest number of these. Yeah, exactly. So our answer will need to be 3 sig figs. So this is the one we're going to choose. So we're going to keep these 3 for sure. Oh, yeah, no worries. And so we need to now look at the next number. We look at this 2. And so that tells us we round down. And so our final answer will just be 49.4. Okay, if it's rounded down, you just cut off everything else. Just get rid of it. All right, so our answer here is going to be 49.4. Perfect indeed. Alrighty, let's do another. How about we can do this with multiple. It doesn't have to just be 2 numbers. So 64 times 0.206. Okay, cool. So plugging this thing in, you get this craziness. Ha. Very nice, very nice. I love it. Okay, so absolutely right. 4 sig figs, 2 sig figs, 4 sig figs. So our answer needs to have 2 sig figs. So again, we're going to look at the leftmost numbers. We're going to keep those. And so now I'm sorry, let me be consistent. I'll use blue. We look at this guy. That tells us round down. Aha! Got you, Sabina. Ha ha ha. Yes, indeed. So now we'll round that to 13. Okay, so it doesn't matter if we're multiplying 800 numbers. What we need to see is we want to convey our lowest significant number. Okay? It's not. You say that now. Once tomorrow starts, you'll see once we learn to add and subtract sig figs, things will get fun. I'll just give you a hint of what is to come. So, this is, this tends to like completely mess up students who are taking math at the same time. Yeah, so we're gonna see tomorrow why 100 plus 16 is just 100. So, ha. So that'll be fun for tomorrow. There's just one more thing I want to throw out. Since we were talking about sig figs today. So measured quantities have sig figs. Exact quantities have infinity sig figs. And what I mean by exact quantities is... boom, boom, boom. Look what I have here. 3 pens. 1, 2, 3. I can count them. I know I have exactly 3 pens. Okay? So there's no difference for me to say 3.0 pens. Like, you can't have 0.5 pens. Like, it just doesn't make sense, right? So an exact number will never have sig figs. Alright? So it's just measured things. So I've used a ruler, I've used a scale, I've used a graduated cylinder, I've used a measuring cup, I've used something to form that measure, it will have significance. However, if it's something I can count, there will not be significant figures. It has infinite amounts. So I have 1 dog in my lap right now. I do not have 1.1 dogs. I do not have, 1.0004 dogs. Yeah, okay, so let's see. Blah, 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 blah. Share an online text to someone. Yeah. Yep. So, actually, the textbook stuff is not going to have homework for you. It's just stuff on Canvas. Okay, one more thing. Speaking of... Oh, no, Oz has started barking. He knows that class is over. That's what he's yelling about. Is this Discord? Yes, okay. So one thing I did want you guys to see is I have put something in our little handouts thingy here. This chart here, you're going to want to learn everything between giga and nano. So when you open it up, I want you guys to learn everything between giga and nano, okay? So all of these parts here. Okay, so you're going to just start wanting to learn them, both the name, the symbol, and the exponent part. Okay, we're going to be working with this probably tomorrow. Okay, so you're going to want to start learning it. It's going to make it easier. At some point, you will want to have memorized this. Okay, so with that, there are assignments in Canvas. You may be able to start the significant figures and measurements one. I mean, you will for sure be able to start that. I don't know how far you're going to be able to get. Okay, so have fun. Yeah, so Maya, I think, was wanting to share a book, so perfect. Okay, it looks like someone here is happy to share with you. So just go ahead and talk with these people in the general chat here. So Maya, you can see that, and you guys can have fun. Okay, so very, very good question, Kenji. You're going to take you're either going to scan it if you have a scanner, or you're going to want to take a picture with your phone or something and submit it on Canvas. Yes, all assignments are going to be due Sunday at 11:59. Okay, so since I assigned these today, you'll have 6 days to work on them. Of course, one of them you will not be able to start quite yet, but that's okay. You'll have plenty of time to work on it. Okay, and you'll just submit them on Canvas. I will put a submission box for you guys. You'll just upload them. I'll show you guys tomorrow how to do that. Okay, back to the infinity for a minute. Let's touch that tomorrow, Maya, just because I have to get ready for the next class. Sorry. So we'll deal with that tomorrow. Okay? Sorry to just kind of brush that off. So, okay. So you guys, I will see you tomorrow. Have fun. Stay safe. Enjoy your weekend. No, Monday. Whatever day it is. Okay, see you guys tomorrow.